This is how we calculate the geometric mean. Example, you have to calculate the geometric mean for 12, 9, 11, 15, and 22. You realize there are 5 values given here: 1, 2, 3, 4, 5. So the first method is to say that geometric mean is equal to the nth root of x1 times x2 times x3 all the way up to xn, where n, of course, is the number of values you are given here, which are 5 in this case. So that is equal to, in this case, because our n is 5, it means we shall look for the 5th root, the number that you can multiply by itself 5 times to get whatever that we shall write inside here. So we shall say geometric mean is equal to the 5th root of the product of these numbers. So that's the 5th root of 12 times 9 times 11 times 15 times 20 times 22. So if you calculate that, you will get it being equal to the 5th root of 392,040, which is 13.14. So this is the geometric mean of these values. The other method is when we can use, or when we use a logarithm. So we shall say geometric mean is equal to 1 over n into log x1 plus log x2 plus blah 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 up to log xn. Still our n is 5 because it represents the number of values that we are given in the question, which are 5 in number. Now, when using logarithms, we shall take these values and list them under the number column. Under the number column, we shall list those figures and then write them in their standard form, which is not a must. You can skip this column, but of importance is that you must get the logarithms of these numbers. So if we decided to include standard form column, then we shall have the standard form of 12 is 1.2 times 10 raised to power 1, and the logarithm will be 1.0792. 9 in standard form gives us 9.0 times 10 raised to power 0. In logarithms, okay, looking for the logarithm of this one, you get 0.9542. Standard form of 11 is that one, 1.1 times 10 raised to power 1. Its logarithm is 1.0414. Then that is the standard form for 15, and its logarithm is given there. 22 has this as the standard form, and the logarithm is that one. After we have gotten the logarithms, we add them. That will give us this as the answer. When you add these logarithms, you get 5.5933. Because there are 5 values that we want to look for their geometric mean, we shall divide this logarithm by 5. So we divide by 5, that gives us 1.1187. So this is the logarithm of the geometric mean of these values. This is the logarithm number for the geometric mean of these values. So we shall say the geometric mean will now be the antilog of this value we have calculated here, which if you check using your calculator or logarithm tables, will give you 13.14. That is the geometric mean for these values.